look at the universe, we see billions of stars, galaxies, planets, and countless structures of different shapes. Each of them has unique characteristics. The deeper we go, the more details we uncover, and it feels as if we're falling under a spell. Everything becomes even more fascinating. But there are regions in the universe that we know exist, yet we can't reach them or obtain any direct information about them. These unseen regions are what we call dark matter. Today, we're going to talk about dark matter. But before we begin, don't forget to subscribe to my channel, like this video, and share your ideas in the comments for future topics. Now, if you're ready, let's dive into the mysterious depths of dark matter. Let's start by understanding our universe. Our universe was born about 13.8 billion years ago from a tremendous event known as the Big Bang. According to the most widely accepted theory, before this explosion there was nothing. No matter, no energy, no time, and no space. Just pure darkness. Then, after this explosion, the universe began to expand, and in a sense, time itself began. In the first seconds of the universe, temperatures reached trillions of degrees. Under these extreme conditions, particles separated, energy transformed into matter, and the first fundamental building blocks appeared: protons, neutrons, and electrons. As the universe continued to cool, these particles began to combine, forming atoms. At that time, there were still no stars, no galaxies, and no planets, only what looked like an endless ocean of gas. After about 400 million years, these gases began to clump together, forming the first stars and galaxies. From this point on, the universe started to take the shape we see today. However, scientists noticed something strange. When they measured the rotation speeds of galaxies, they found an inconsistency. The visible matter wasn't enough to hold the galaxies together. According to the laws of physics, they should have already drifted apart into the emptiness of space. There had to be something invisible, some kind of matter, stars, black holes, anything, holding them together. But scientists couldn't find anything tangible. That's when the idea of dark matter was born. Dark matter is like the invisible skeleton of the universe. We cannot see it with our eyes or detect it with telescopes. It doesn't emit or reflect light, but it reveals its presence through gravity. Galaxies, stars, and everything else revolve around it. It binds the cosmos together. According to scientists, all the normal matter we can see, stars, planets, dust, humans, animals, everything, makes up only 5% of the universe. The rest is composed of 27% dark matter and 68% dark energy, which is even more mysterious than dark matter itself. The idea of dark matter was first proposed in the 1930s by astronomer Fritz Zwicky. While studying the Coma galaxy cluster, Zwicky realized that the galaxies were rotating much faster than expected. His calculations didn't make sense. It was as if the galaxies were being influenced by some massive, unseen force. He called this mysterious component dunkle Materie, which in German means dark matter. Later, in the 1970s, astronomer Vera Rubin studied the rotation speeds of galaxies and reached the same conclusion. The stars in the outer regions of galaxies were moving just as fast as those near the center, something that shouldn't be possible. Normally, the outer parts should rotate more slowly because they contain less mass. This meant there had to be an enormous invisible sea of mass surrounding them. Rubin's research made the existence of dark matter almost undeniable. We now knew that galaxies were spinning within an invisible skeleton, and this skeleton was made of dark matter. But here's the most fascinating part. Where is this dark and mysterious matter? No one knows exactly where it is or where it begins. Some scientists believe dark matter is made up of particles called WIMPs, weakly interacting massive particles. These particles barely interact with normal matter, but they reveal their presence through gravity. Another theory suggests that dark matter consists of exotic particles known as axions, which behave almost like ghosts, invisible but subtly influential. And some researchers go even further, suggesting that dark matter might not be matter at all, that perhaps it's our understanding of gravity that's incomplete. And honestly, that could be true. Maybe the universe operates under laws that are different from what we think. What's impossible according to our physics might be completely natural somewhere else in the universe. For example, We believe that no living being could survive in extremely hot or cold environments. They wouldn't be able to reproduce or evolve. But what if we're wrong? Perhaps life as we know it couldn't exist in those conditions. But maybe somewhere in a distant galaxy, there are beings that live comfortably under what we consider impossible environments. Maybe for them, our planet is the one that's uninhabitable. And there's something else. As you know, all living organisms on Earth tend to evolve. They adapt to changing conditions to survive. Those that fail disappear, and the successful ones evolve further. So maybe millions of years from now, some species on our planet might also evolve to survive in what we now call impossible conditions. In that sense, the scientists who argue that our knowledge of gravity is limited might be right. Maybe the laws of physics as we know them are just a small part of a much bigger truth. But regardless of what the real explanation is, the effects of dark matter are undeniable. Without it, galaxies wouldn't hold together. Stars would drift apart, and the universe could never have formed as we see it today. In a way, dark matter is the invisible glue of the cosmos. For decades, scientists have tried to detect dark matter directly. In laboratories such as CERN, enormous particle accelerators search for traces of these elusive particles. Deep underground, sensitive detectors are built to capture rare interactions between dark matter and normal matter. But so far, no direct evidence has been found. This complete silence, this absence of any detectable signal, only deepens the mystery. Still, scientists are not giving up. Using cutting-edge telescopes, next-generation analysis tools, and even artificial intelligence, they continue their search to finally reveal this hidden component of the universe. Yet, as of now, the mystery remains unsolved. There's also one more thing. Many people confuse dark matter with dark energy. As mysterious as dark matter is, dark energy is even more fascinating. Because it doesn't just hold galaxies together, it actually accelerates the expansion of the universe. Here's how it works. The universe is expanding, but this expansion isn't constant. For example, if it grew by 1 unit on the first day, it grows by 2 units the next. The rate of expansion keeps increasing. According to scientists, what causes this acceleration is dark energy. Dark energy was first discovered in the late 1990s by 2 independent teams of astronomers. They were studying supernovae, gigantic stellar explosions, to measure how fast the universe was expanding. They expected to find that the universe's expansion had slowed down over billions of years since the Big Bang, because the gravitational pull of galaxies, stars, and all matter should gradually decelerate it. But the results shocked everyone. The expansion wasn't slowing, it was speeding up. That discovery shook the entire scientific community. There was no known law of physics that could explain it. And from that moment, a new concept emerged: dark energy. Dark energy acts like the driving force of the universe, pushing galaxies away from each other and expanding space itself. Right now, this mysterious energy makes up about 68% of the total energy of the universe. So when you think about it, dark energy is even more abundant than dark matter. But where does it come from? Unfortunately, the answer is the same as with dark matter: we don't know. Some physicists believe that dark energy originates from space itself. You see, what we call empty space isn't truly empty. According to quantum physics, even in a perfect vacuum, tiny virtual particles are constantly appearing and disappearing. This restless movement of energy is called vacuum energy. So, dark energy might actually be the large-scale effect of this quantum activity, the cosmic echo of the vacuum itself. Another theory proposes that dark energy is a new cosmic force, one that actively stretches the fabric of space. And maybe, just maybe, the universe is consciously programmed to expand, functioning like a living organism. In that sense, the universe could be seen as alive. It is born, it grows, and it changes, just like us and every living being on Earth. But dark energy doesn't only affect our present or our past, it also shapes our future. If the universe continues to expand at its current accelerating rate, then billions of years from now, stars will drift so far apart that we'll barely be able to see even our own galactic neighborhood. Eventually, no other galaxies will be visible in the night sky at all. You might have heard that our moon moves away from Earth by about 3.8 centimeters each year. This is part of the same process. Everything in the universe is slowly drifting apart. If this continues, one day the universe will grow cold, dark, and silent. Scientists call this ultimate fate the Big Freeze. Of course, as with many things in science, there are other theories too. Some scientists believe dark energy might be part of a cyclical rhythm, a cosmic breathing of the universe, constantly expanding and contracting in an eternal loop. Maybe one day, the universe will collapse back in on itself, only to explode again in another Big Bang, starting a new cycle of creation. At least, that's what some scientists suggest. Meanwhile, researchers around the world are eagerly following each other's discoveries, all in hopes of finally uncovering what dark matter and dark energy truly are. And people like us, those who may not conduct experiments but share the same curiosity, wait with the same excitement. Who knows? Maybe one day, as our channel grows, we'll visit these research centers together and meet the scientists working on these mysteries. Only time and patience will tell. As you can see, even what we can observe in space is enough to fill us with wonder and excitement. But when you realize how many unseen, unimaginable, and mysterious things exist beyond our reach, everything changes. All it takes is a small shift in perspective. So, that's all we can say for now about dark matter. A structure whose presence and influence can be clearly felt, yet cannot be seen, touched, or heard. Maybe it's even a sign that we need to rethink the laws of physics as we know them. But that's all from me for today, my friends. I truly believe we've explored an incredible topic together and learned some valuable things about our universe. If you're as fascinated by space, galaxies, and the mysteries of the cosmos as I am, don't forget to subscribe, like the video, and share your thoughts in the comments below. I read every one of them, and your opinions truly matter. For now, that's it from me. Until next time, take care of yourselves, and see you in the next video.